Determine the area of each polygon. Remember, for rectangles and parallelograms, we use the formula A equals base times height. For triangles, however, triangles are half of rectangles or parallelograms. So we use base times height divided by 2. Another version of this formula that you might see is 1/2 the base times height. In our class, we discussed that dividing by 2 is the same as multiplying by 1/2, because when dividing by fractions, you can change it to multiplication as long as you flip the second fraction over. So in some circumstances, I prefer to use dividing by 2, while in others, I might prefer to use the fraction version. Let's look at number 3 together. 13.5. I can change that into an improper fraction by multiplying the whole number and the denominator. 13 times 2 is 26, and then I add the numerator. So 26 plus 1 is 27/2. So now in this formula, I have 1/2 times the base, which is 9, or 9/1, times the height, which is 27/2. Then I can multiply. 1 times 9 is 9, and then 9 times 27 for the numerator, which is 243. Then 2 times 1 is 2, and 2 times 2 is 4. You can leave that as an improper fraction, or if you wanted to convert it into a decimal by dividing 243 by 4, that would give you an area of 60.75. Please complete problems 1, 2, and 4 on your own. This is a digital lesson. If your teacher does not have it open through Great Minds, you can just follow along in the video and take notes in your workbook. Slide 1 says, move the points to decompose the polygon into rectangles. So I'm going to move this point over. Or down to cut it into a rectangle. You could also create rectangles going this direction if you prefer by sliding the points over. The choice is up to you, but we need to cut it into rectangles. Slide 2 says decompose the polygon into rectangles in a way that you think no one else in class will. Maybe we're going to make it into many small rectangles rather than 3 larger rectangles. Slide 3 says let's focus on finding the unknown measurements in the polygon. Decompose the polygon into rectangles. So let's start there. Move the bold line segment to help you find the unknown measurements. Fill in the blanks with the unknown measurements. So if this piece is 5, that piece is 5, and this piece here would also be 5. And then we'll hit submit. We still need to fill in this piece here. If this piece is 5, but the whole thing is 11, in order to make this whole distance here, 5 plus 6 has to make this whole side equal 11. Decompose the polygon into rectangles and move the line segment to help you find the unknown measures. Fill in the blanks with the unknown measurements. If this piece up here is 3, this piece must also be 3. If this part of the rectangle is 4, the bottom part of the rectangle also must be 4. This whole thing is 10. I have taken out a chunk that is 4 and a chunk that is 3. 10 minus 4 is 6. 6 minus 3 is 3. So this middle chunk must be equal to 3 for all of the pieces to add up to 10. 3 plus 3 plus 4 makes 10. This piece here is 5, so this missing piece needs to be 6 in order for it to equal 11. 5 plus 6 equals 11. Describe how you found the unknown measurements. I knew that the vertical or up and down side length had a total of 11. The 5 centimeter piece plus the 6 centimeter piece must equal 11. I also knew the horizontal, or the one across the bottom, was 10. I had a piece that was 3 centimeters and another piece that was 4 centimeters. Three plus 4 plus another 3 has to equal 10. So that missing piece in the middle had to be another 3. Find the area of the polygon in square centimeters. This piece was 3, this piece was 3, and this piece was 4. This has a base of 4, and the whole height is 11. Base times height, 4 times 11 is 44. This piece has a base of 3 and a height of 11. 3 times 11, base times height, is 33. This center piece is 3 wide. This piece was 5 tall, so to get 11 tall, we needed a 5 plus a 6 makes 11. So this rectangle in the middle has a base of 3 and a height of 6. Base times height. 3 times 6 is 18. So for the area of the polygon, we need all 3 of those rectangles combined together. So 33 plus 18 plus 44 will tell us the area of the entire polygon. And that is 95. If our answer is correct, remember that it's going to fill in the entire shape with no extra. Let's put in a wrong answer just to see what would happen. If it's below, we have empty space. And if we put in a wrong answer that is too high, we are going to overflow our shape. If our answer is correct, it should fill the shape exactly to what it needs to be. Find the area of the polygon in square meters. Use the interactive to show your work. So I'm going to break it up into shapes that I know how to find the area of. There's a rectangle. It has an 5 base and an 8 for its height. Base times height, 5 times 8 is 40. This is a trapezoid, but I can cut it into a triangle and a rectangle. This has a base of 6, but the height is not 8. It doesn't go all the way to the top. This 2, not centimeters, meters, takes up part of it. So if the 2 takes up part of it, the rest of it has to be 6 in order for it to add up to 8. So this has a base of 6 and a height of 6. Base times height, 6 times 6 is 36. This distance here is 5. This distance here is 6. Well, 5 plus 6 is 11. So I need 3 more here to make 14. And the height is 6. It matches this piece here. For a triangle, we do base times height, 3 times 6, and we split it in half. 3 times 6 is 18, but half of 18 is 9. For the area of the entire shape, we need to add 9, 36, and 40 together. 9 plus 36 plus 40 is 85. When we check, it should fill the shape perfectly. In your workbook, you have page 119 has a removable trapezoid shape. We're going to discuss one strategy that can be used to solve for the area of a trapezoid. I can cut it into 2 triangles. This triangle on the bottom has a base of 8 and a height of 5. But it's a triangle, so it gets divided by 2. 8 times 5 is 40. 40 divided by 2 is 20. This upper triangle has a base of 4, but it also reaches a height of 5. And since it's a triangle, we divide it by 2. 4 times 5 is 20. 20 divided by 2 is 10. So the entire trapezoid is made up of a triangle with an area of 10 and an area of 20. So its entire area is 30 meters squared. There are several other ways that you may choose to decompose your trapezoid to solve for its area. You may choose to create 2 triangles and a rectangle in the center. You may choose to cut your trapezoid diagonally the other way, creating again a 4 by 5 and an 8 by 5 triangle. You may also choose to take these triangles here and here and combine them to form one large triangle and then the remaining or resulting rectangle in the center. So one large triangle and one rectangle. There are many strategies, and you may even see formulas that can be used for finding the area of the trapezoid. But typically it's just one more thing for us to try and memorize. So instead we think of strategies that would apply to more than one situation. The rest of this lesson is going to take place in your workbook, so we're done with the digital piece of it. I prefer the two triangle method for finding the area of a trapezoid. This pink triangle here has a base of 0.8. And a height of 1. 0.8 times 1 is 0.8. 0.8 divided by 2 is 0.4. Then let's find the area of this big blue triangle. The base is 2.4. The height is 1. And since it's a triangle, we still have to divide by 2. 2.4 times 1 is 2.4. That answer divided by 2 is 1.2. For the total area, we add these together. 4 plus 2 is 6. 0 plus 1 is 1. Look for the units in your problem. We have inches, and area is inches squared. Which expressions can be used to determine the area of the trapezoid in square centimeters? Choose all that apply. Well, if we cut it into a rectangle and a triangle, the rectangle is 9 by 4, and the triangle, if this piece is 9, but this piece extends all the way out to 12, 9 plus 3 makes 12. So the triangle is a 3 by 4, and we have to split it in half. Here I see 4 times 9, which would be this rectangle piece. And half of 3 times 4, which would be the triangle piece. So A is correct. If we use the method where we cut it into two triangles, we have a triangle that is 12 by 4 tall, and a triangle on the top that is 9 by 4. I see this represented in C. A less common strategy that people may try is if they created 2 of these trapezoids and turned it into a rectangle. This piece was 9, this piece was 12, and this piece was 4. So if we wanted to find the area of this whole rectangle, we could add these 2 for the base, and then times it by the height. But since I did 2 of them, I would need to cut this in half at the end, since I only want 1 of them. This is represented in part D. You can do 9 plus 12 instead of 12 plus 9 because of the commutative property. And E, we have 1/2, the 4, and the 9 plus 12. This one is incorrect because it doesn't cut it in half. This one is incorrect because it uses the 5. Remember, we talked about how the 5 is a number that's going to be put in to try and trick you. The diagonal is not used as either a base or a height. And in this one, they did half of the rectangle piece, which we do not want. So you should have A, C, D, and E selected for problem 2. Determine the area of the polygon. Show your work. You can think of this as 4 small triangles, or we can select it as 2 larger larger triangles. If we're looking for the base here, this whole base is built from 21.6 and 8.1. So this whole base is 29.7. The height of that triangle is 10.8. And since it's a triangle, we have to divide it by 2. The blue triangle has the same base. Its height is also 10.8. And since it's a triangle, it needs divided by 2. So the area of each of these triangles is 160.38. Now we need the total area. We can add those together, which is 320.76 feet squared. You may have tried an alternative strategy. Another method you might use is to turn this into a large triangle here and a large triangle here and add those together. Or you can use the 4 small triangles and add all 4 of those together. Scott covers the floor of his room with carpet. The diagram represents the floor of Scott's room. What is the total amount of carpet Scott needs to cover the floor of his room? Let's cut it into 2 rectangles. This rectangle has a base of 12 and a height of 9. So base times height, 12 times 9 is 108. This rectangle has a base of 4, but our height is missing. I know the whole height is 12, and this piece of it, from the top to here, was 9. 9 plus what number makes 12? 9 plus 3. So this rectangle has a base of 4 and a height of 3. Base times height, 4 times 3 is 12. So the entire area of the carpet is the 108 plus the 12, which is 120 feet squared. Draw a polygon on the grid that is not a parallelogram and that has an area of 18 square units. Each square on the grid represents 1 square centimeter. So we can't draw a parallelogram. And since we can't draw a parallelogram, rectangles and squares are out as well. Because rectangles and squares are categories or specific types of parallelograms. But I could draw a triangle. If I drew a triangle, the formula is base times height divided by 2. This is saying the area is 18. To undo dividing by 2, I can multiply by 2. So that says 18 times 2 is 36. And that leaves me with the base times the height. So I need two numbers that multiply together and make 36. Well, 6 times 6 makes 36. So I could have a 6 cross and 6 tall right triangle. Base times height, 6 times 6, 36, divided by 2 is 18. You could also create a 9 by 4. 9 times 4 is 36, but there aren't 9 squares across. What if we created a shape that was composed of a rectangle? Like this piece here is a rectangle that's a 4 by 4, so it has an area of 16. So we need two more. If I created a triangle that was 2 by 1, 1 times 2 is 2, but since it's a triangle, I would have to divide by 2, so that would only give me an area of 1. What if I created a 2 by 2 triangle? 2 times 2 is 4, 4 divided by 2 is 2, so 16 plus 2 would make 18. So I could make a shape that looks like this, that has an area of 18. You might even make a trapezoid that has an area of 18. There are many correct answers to problem 5. You just need to draw one polygon, but it can't be a rectangle, a square, or a parallelogram, and it must have an area of 18. That's all for lesson 7. Lesson 8 should be up soon.